When the wind hits a mountain or moves to higher elevation, it is forced to rise. The rising motion helps the air cool and moisture condenses into precipitation. This process produces cooler and damp weather, especially if the air has to rise a significant vertical distance. By the time air reaches leeward side of mountain, much of its moisture has been lost, resulting to region of rain shadow. Frontal wedging occurs when cold air meets warm air. The warm air will be forced up. There is two types of fronts, which is cold front and warm front. In the case of a cold front, a colder, denser air mass lifts the warm, moist air ahead of it. As the air rises, it cools and its moisture condenses to produce clouds and precipitation. Due to the steep slope of a cold front, vigorous rising motion is often produced, leading to the development of showers and occasionally severe thunderstorms. During warm front, the warm, less dense air rises up and over the colder air ahead of the front. Again, the air cools as it rises and its moisture condenses to produce clouds and precipitation. Precipitation that develops in advance of a surface warm front is typically steady and more widespread than precipitation associated with a cold front. When winds from two directions meet and the only way to go is up. That is how convergence processes occur. In the center of low-pressure areas, winds converge toward the center of the low due to the effects of friction. The stronger the convergence, the stronger the vertical motion, and the more clouds and precipitation are likely to fall. As the Earth is heated by the sun, thermals rise upward from the warm surface. It cools as it rises and becomes diluted as it mixes with the surrounding air. An air parcel will rise naturally if the air within the parcel is warmer than the surrounding air. Therefore, if cool air is present aloft with warm air at lower levels, thermals can rise to great heights before losing their buoyancy. If a thermal is able to rise high enough to cool to its saturation point, the moisture within condenses and becomes visible as a cloud.